Hey guys, this is Algebra for Faith, and today's lesson is for May the 6th. I'm doing this on May the 4th, so most of you all just picked up your quiz for Chapter 10, so hopefully that went well. We are starting Chapter 11 today. Chapter 11 you're not going to have time to take the test on, but we are going to go ahead and try to do Chapter 11 because Mr. Matthews and I discussed that you really need to get familiar with radicals for Algebra 2, maybe for geometry coming up. And so it was agreed that we would go ahead and try to get this all together and at least expose you a little bit to radicals. So before we get into today's lesson, let's go ahead and take a brief word of thanksgiving to the Lord in prayer. Heavenly Father, we just want to praise you and thank you for today and for everything that you've given us. And Father, we pray for our world and we pray for us, Father. We're sinners and we're in a condemned world and we just need you so much. And we praise you and thank you for giving up and sacrificing your Son for us. We love you in Jesus' name. Amen. All right, guys, so today's lesson is basically just kind of self-explanatory stuff. We're just mainly taking the time to make sure you understand the process of what square roots are, the process of cube roots, and things like that. What I'm getting ready to write out here on the board, which right now I'm looking for a red pen, yeah, here we go, is what I'm probably going to leave up on the board, hopefully, for this entire chapter, and it's so you can get familiar with perfect squares, get familiar with perfect roots, so hopefully you can just recognize those, and as you're trying to kill yourself and trying to figure this stuff out, if you recognize a perfect square, a perfect root, you won't have to punch everything in your calculator and things like that. So let's go over what our perfect squares are. They recommend that you know your perfect squares from 1 all the way through 20. I'm getting ready to go through each one of those. You probably learned this 7th and 8th grade maybe, 5th or 6th you may have learned some of them. We're also going to learn cube roots as well. You probably know at least a few of your cubes. I can keep them in my head up to 3. So if you don't know them, that's perfectly fine. But I'm going to leave this over here so we can kind of reference it back and forth, as well as this is kind of our lesson opener for today to just get you back into it. So of course a square root is a number multiplied by itself. So 1 times 1, the square root of 1 times 1 would just be 1. 2 times 2 would be 4. 3 would be 9. See, most of these we know pretty good, right? So all of these you probably learned as twins. That's how I remember my children learning them. And then, so you probably learned them all the way through here. And this was probably, y'all did your multiplication tables through 12, and so most of the time, those square roots are in your brain. It's really difficult to get them out of your brain. Then is where you start to go, huh? So what I'm doing, all of these was 12 times 12, 11 times 11. So what's 13 times 13? That's 169. 14 times 14 is almost just swapping the number, 196. 15 times 15, 225. That one I can normally keep in my brain, and that's the only one. 16 times 16 is 256. Going down. Sorry, there's just a bunch of them. 17 times 17, 289. 18 times 18, 324. 19 times 19 is 361. And finally, this one you could probably get with no problem. That is simply 400. And we did this at the first of the year a little bit, but it's always good just to have a table we can reference back and forth. Now let's go to cube roots. So, if I fall, I'm falling over my cord. So if we go to cube roots, this is where we're multiplying the number 3 times. So 1 times 1 times 1 would simply be 1. Like I said, most of the time I can keep up with 2. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is, that's 8. And most people can remember 3. 3 times 3 times 3 would be 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6 times 6. This is one that just seems to launch out of nowhere. You know, all of these seem kind of familiar, but get to 6, the cube root of 6, you're like, where did this come from? And then it comes more and more bizarre. 343 for 7, 512 for 8, 729 for 9, 10 shouldn't be that difficult. That would be 1,000. So we may reference these going back and forth in our lesson for probably this entire chapter. We might just reference all the way back over here and say, okay, so that's what it is. So my recommendation in my teacher's manual was to go over these perfect squares and to go over these perfect roots every day to get them suspiciously into your brain. We are going to go over all the definitions that's in this, and I really love how some of you have really helped out your fellow classmates, or not helped out. Actually, I don't care, because I still have, all right, today's, May 4th. I'm still getting people who are turning in homework, which most of you all, if you actually watched a video, know I told you not to do homework. Isn't that kind of funny? Don't worry too bad. I think most of these people are just doing the odds and just writing the stuff from the back of the book. But that's okay. You really didn't have to do homework. Well, from now on, just to see if I've got people who are watching, we're actually going to take your quiz, which you probably already have in your hands, hopefully, and I'm going to do some quiz questions with the day's lesson that it pertains to, just to see if I've got people watching, which means some of you might get an easy quiz grade. And remember, no tests anymore. All we have are quizzes. So from now on, if you're listening to this lesson, grab the quiz for it, and I may go over some of the quiz questions on it just to help you guys out. So let's look at square roots. If you say we've done this before, we've done it before. Doggone it, this thing is like all wrapped around. I don't think this is how I'm supposed to do this thing. I thought it was going to go the other way. I'm tripping over my cord, so that's my issue. So I'm trying to move. All right. Not working here. Now I'm running over the cord. Yeah, I can already set. I'm going to have to completely redo something for this. So let's look at square roots. We have done this in a previous chapter. Yes, we have. But we are now on page 432. This entire chapter is on radicals. And like I said, next year's math teacher is kind of wanting me to just make sure that you know all the things you can about the square root and radical signs. A square root, of course, and if you just have a radical sign, it's assuming it's a square root. I know I walked out of frame, that's okay. So that's square root. This is a radical sign. A number that we're going to put down underneath it is called the radicand. I am simply reading. You could go along with the reading that's on page 432 in your book. Then, what we've dealt with up to now is when you pull out a square root, technically it would come out as plus or minus. You couldn't tell it. Remember, we had some of these right at the beginning where you couldn't just put 9 or you couldn't put just 3 down. You had to put plus or minus 3, and then technically you would come out with 2 answers for stuff, one with the positive, one with the negative. Well, now they're talking about, to avoid confusion, mathematicians have agreed to use the radical sign to indicate the positive square and to put a negative sign in front of it to indicate the negative sign. Also, in case we've got something that's completely different from a square root, we would use an index number, which technically would just be n, and an n would go to whatever. All right, sorry, I'm gonna have to, this is not working. Take you for a ride while I try to figure out how to fix my cord. Yeah, I think that will work better. I think I just got it jerked into the wrong position or something. It was weird. All right, so when we looked at the radical sign, there we go. Technically, if we put a little number there, that's called the index number. For instance, to do a cube root, which we've already done over here, we've got, I placed that there, that's the cube root. Any number up above that, we've got square root for a 2. We have cube root for a 3. Any number up above that is going to be the n root or the nth root. You put the number there that you want. Now I've got a hair stuck in my glasses. On your calculator, while we're doing this, while I'm thinking about it, yes, you could technically do these on your calculator. We're going to talk about it a couple of different ways. You may not figure out your Texas Instrument one because I don't like those. But if you have your iPhone in front of you, or if you have your Android, I'm sure their calculator is very similar. This way is easy peasy, basically a tip calculator, tax calculator. This one becomes scientific calculators. And guys, there's tons of scientific calculator apps you could also download too if you wanted one more complex. And if you notice right here, you have a series of radical numbers. Siri thinks I'm talking to her. All right, here we go. You have 3 buttons that have radicals with them. And as you can see, you've got the square root one, you have a cube root one, and then they have one where it just has y. X is the radicand, y is the n term, and that's where you can put in any term you need to get a root of. So that's what we're going to use. But technically, we're going to deal with perfect squares, or we're going to use estimates of those. Do you have to actually memorize these weird roots? No, because weird roots, weird cubes, weird n terms are irrational, and that would just be irrational to learn all of those. So for your test and for your quiz, you need to kind of know what you're doing on example 1, and you kind of need to know what you're doing with example 2. So what am I doing with example 1 and example 2? Well, we can look at them. They're pretty simplified. Eraser over here. I think I've gone successfully through all that stuff that you're going to do in a quiz later, but I'm going to do another one too. So let's look. If I'm trying to figure out the square root, then technically what I'm doing is I'm saying what were 2 numbers that were multiplied that got this number? What were the same 2 numbers that were multiplied that I was able to get that? And they break it down and do an extra step for you, but they're doing this so when you get into a weird variable situation, you'll understand it. You'll go, oh, that was 2 squared, or that was 2 times 2. And then once you figure that out, that they have you pull that out. If there's a number under there that's squared, you can go ahead and pull it out from underneath the radical sign, which would just be simply a 2. Then they've also given you the example of a negative radical of 16. Same difference. What are the 2 numbers that were multiplied to get 16? Technically, it would become 4 squared. If it's squared under there, I can go ahead and bring it out. This negative, still making it negative, so it would be 4. That's just a real simplistic way of doing it. Once again, example 2 is finding the cube roots. If you don't know these, we went over them. So we just did this. So if nothing else, you could write this stuff down, or you could plug it into those 2 buttons that I showed you for cubes, the cube one and the square one. So I'm going to see, since we've got you together, we have nothing better to do. I'm going to flip my thingy over. I am going to plug in 16. I'm going to hit, I want to know what the square root of that is, so I click the one that had that. I'm going to put in 8. I want to know the cube root of that, so I'm going to hit the one that has the little index number of 3. Tells me it's 2. So either memorize these, and it's not bad to memorize, at least a lot of the perfect squares should make it really easy, because that took a little while. Or use your numbers that are on your calculator. And now, since most of you lose your calculator, but you always have your phone, you might know how to do that. Let's go on and look at our next section. So the next section is where you're trying to find the indicated roots. And here's a thing that they just want you to recognize right off the bat. If you've got, for a square root, while this is a rational number, technically this is not a rational number. So that if you recognize a negative, or sorry, I didn't say rational, it's not a real number. You have a negative under a square root. That is not real. It is not a real number. And that's what you should put down when you have one of those. If you look at B, when they're trying to get the cube roots of those, I think there's a mistake in yours, that they basically, it was a fraction, but they went ahead and got the cubes of each, the numerator and the denominator of those fractions, and then took it. I'm not going to write all this stuff down because I have another one I want to do with you. And then I was going to see, do we have one of those? No, I had that written down for, you technically have a cube root that you have to find for your, I already put it over there, the cube root that you have to find for your quiz. So just making you know that. Example 4 is what you have to do. This is not going to help you. Yeah. Because in life, let's just say, due to solar flare activity, everything got burnt out, including our calculators and stuff like this. This is probably what we'd end up having to do. We would end up having to basically mentally estimate what the square root of these irrational numbers would be. And an irrational number would be a number that's not a perfect square, or not a perfect cube, whatever the case may be. So, this one might be one on your quiz. And it's basically asking me to estimate what the square root of 40 would be to the nearest integer. So what do I have to do? I have to figure out what would be 2 square roots on either side. Not square roots, but yes, first squares. So we could go all the way over here. Remember, we want one that's bigger, we want one that's smaller, right? And let me make sure I've got that going down. Yeah, like that. I want something that could come out, a perfect square that would be below 40, and I want a perfect square that would be above 40. Let's slide on over here to our perfect squares. I want one that's above 40, and I want one that's below 40. Do you see the perfect squares? If I was like, Dora, point to the perfect square. So what do we have? We have a 36, right? 36. And then we have a 49. Yay! We have 36 and 49. All right. So I have no clue what I do. It'd be like some weirdo decimal that would come out. I have no clue what 40 would be, trying to pull it out. I remember them they would give you these tables with all these decimal numbers in the back of your book, and you would have to look it up, and it was like miserable. So what would be the square root of 36? That would be a 6. What would be the square root of 49? Oh, that would be a 7. And then I think about this a little bit. So I'm mentally estimating it to the nearest integer. Which one would it, I know it would be between those two integers, but which one would it be the closest to? Well, then I have to consider which number is closest to 40. So between 36 to 40, and you can subtract if you wanted to. So between 36 and 40, I basically have 4 slots. If I subtract 36 from 40, I've got 4. But if I subtract 40 from 49, I've got 9 spots, or I have 9. So which number is it closest to? It's closest to this one. So if I was going to mentally estimate what it's closest to, the square root of 40 is going to be closest to 6. That might be really similar to one on your quiz. Now, let's go over to your next page And look at, again, just some understanding that we're doing some things on. And they give you a long definition on the top of page 434, where they're talking about how you come up with all this information of where technically a square root would be an exponent with a fraction. Rather than go through all of that, let's go on over here. Yeah, I'm a little short, but I don't want to show you all that we're getting ready to do. I would start looking at the definition there for your quiz. That's on page 434. So basically, if I have a number with a fraction as an exponent, then I'm going to use b as the index number, and the exponent that's on the top, the numerator, is going to go underneath the radical sign. Another way to write that is b is still the index number, and it would stay in parentheses, and then this exponent that would be underneath would come out of the parentheses and be here. And then they gave you an example of a number using 8. So 8 to the power of 2/3. That index number would come right here. It would be a 3. The 8 square would stay underneath. Another way to write that is 8 to the power of 3 would be right there. And then outside the parentheses, I'd have the exponent of 2. So what you have to do on your test is they give you, well, I'm going to show you two things. First, a cube root. Here we go down. This may be one that's on your quiz, right? A cube root. A cube root of negative 64. Well, first of all, some of you are going to say, wait a second, a square root, a negative number, not real. No, this one technically is real. So having a negative cube root is perfectly fine in the real world of numbers, not a negative square root or a negative underneath the radical. So what could be the cube root of 64? Let's go look at our perfect cubes. So perfect cubes, here we go. My cube root I'm looking for is 64. Do you see the 64? Point to the 64. Yay! Now I feel like I need to sing backpack. So that's what we did, is technically we went ahead and said, okay, a negative 4 would be the cube root of a negative 64. And then I would go ahead and pull that out as just negative 4. Now let's talk about some quiz questions where you're using exponential form. Going to go down to this first section. So I start out, it has all these numbers underneath the radical sign, and then on your quiz it'll ask, write this in exponential form. Remember, this index number is my numerator. And then all the exponents that go with the things underneath the radical sign will be my numerator. If it doesn't have an exponent, then automatically it's 1. Remember that from below so many months ago? So here we go. We have my numerator is going to be a 3. My 3 will have an exponent of 1 over 3. My x will have 1 of 2 over 3. And my y will have 1 of 1 over 3. So that's me taking this radical and writing it into exponential, meaning exponent, form. You also have a question on your quiz that's converting to a radical form. So it's an exponential form, as you can see right here, and I'm supposed to convert it to a radical form. But look what the issue is here. Oh no, my exponents or my denominators are not the same. You have to have the same index or the same denominator. You get the same index the same way you would get the same denominator in fractions. So I want it to all be 1/6. So I'm going to multiply the 2 and the 3 by a 2, right? No, 3. Yeah, 2. And then on the 1 and the 2, I'm going to multiply that by 3. So now I get a common denominator or a common index or whatever you want to say of 6. Now I can move that over here. I can go ahead and move that over into 4 to 4 squared. X just had a 1, so I put it in there as x. Y had a common denominator 3. And then my index number or my denominator from my exponents goes right there. Technically, you could go ahead and finish out the 4 squared to 16. If you don't do that, it's not wrong. Okay, this number is perfectly as acceptable as that number. So if I was going to practice this, just so I can get some exponents in my head, I would probably practice doing 1 through 39 odd, just so I could get some practice in on how to do these things. Remember, you do have to do a cube root. I've given you examples of each one on your quiz, so it should help you with your quiz. So I'm not going to do any homework problems. And so instead of doing homework problems, I'm going to try doing some quiz problems and seeing how many people actually watch those, right here at the end. So that is your lesson for the day. Hopefully you can now have time to get out and run around and act like a maniac if it's pretty outside and it's not cold. And so have a good rest of the day, and we miss you guys, and we'll see you later.